Okay, hey everybody. So my name is Kevin Reece. I'm here to talk to you a little bit about applying code standards retroactively. So a little bit about me. I'm from California, Colorado, and Arizona. I graduated from BYU's computer science program back in December, and I've been at Lucid Software since April of 2016 as an intern, then a part-time, then full-time employee. I'm a software engineer there. So a little bit about Lucid. Hopefully you know a little bit about us already. We were founded in 2010 by Ben Diltz and Carl's son. Ben is the mad scientist. Hopefully you were able to go to his presentation this morning and hear a little bit from him. We are in South Jordan. We have two products, Lucid Chart, Lucid Press. Both are web-based. We have a primarily TypeScript and Angular front end with a Scala back end. So what I'll be talking about today is mostly the front end. Well, all the front end, because that's what I do. I work on the front end. So I will not be talking about the Scala, but just for your information. A couple of disclaimers. I claim no expertise in doing massive refactorings. I am here to give you a report of what my team did this summer. We went through this large refactoring of our code base, did a lot of different things, and I want to give that information to you. Hopefully it can be useful. So as a result, this presentation is very much descriptive. It is not prescriptive. However, I will give some small pieces of advice that I feel are warranted. And any genius behind anything that I show here, the credit goes to Ryan Stringham, who is my manager and the technical lead of our team this past summer while we were doing this work. So a little bit of background. Like I said, in April, I was put on a team with Ryan, and we were given the task. There were four of us actually altogether. We were given the task of improving the quality of our code base. We were called the dependency injection team because that was our primary objective, but we ended up becoming really the code quality team in general and touched a lot of things, including dependency injection, but also code standards in general. So I'll be talking about a number of those different things. I want to cover three overarching ideas. One, why we decided to dedicate resources to refactoring code and not writing new features. How we went about doing those, some of the questions that we had to answer and problems we had to solve for ourselves, and then hopefully a little bit of advice on how you can avoid needing to do the same massive style refactoring that we did. So first of all, why did we do this massive refactoring? Essentially, we kept running into the same problems. You can see a couple examples up there. One was dependency management between objects. Another was naming consistency between, meaning file names, method names, object names, attribute names, variable names, any kind of name. And then the other was directory navigation, being able to look in our directory, which is massive, and find files that were related to other files and be able to navigate through there and be able to reason about our code structure. In addition, we believe at Lucid that high code quality benefits us in the long run. We have a long-term view of our code quality, and although sometimes we have to make business decisions that benefit in the short run, we do hope that we can build the quality of our code base and that will save us time in the future. In addition, this is a key element. Leadership does trust us. So this is both engineering leadership, product leadership. They believe us when we say, if we take the time to fix this now, it will benefit us later on. And that, I think, is very key, and we were lucky to have leadership that trusted us. So how did we do this? What problems did we have to solve? First, a couple of general strategies. When we decided on a standard, step number one is to stop the bleeding. We need to make sure that we're not introducing additional errors and writing new code that is the old way. So the first step is communicating, making sure that people are aware of this. This can be done through tech talks, through an email, through Slack, whatever you need to do. The other way is to then, or the next step is to then track and hopefully enforce this standard. That's sometimes possible, not always possible, but where it is possible, it should be done. That really goes a long way to making sure that we're not adding new bad code into our repository. From there, once you stop the bleeding, you can either do two strategies. The big bang change, where you just go and fix everything in your existing code base kind of in one sweep, or the alternative is you fix it little by little. We prefer the big bang change because then really it's very hard to enforce standards when existing code doesn't follow those standards. Many engineers do the copy and paste mentality, or they look for an example in the existing code base. And if all code does not conform to the standard, it's hard to get new code to conform to that standard. So we prefer the big bang change. And we are able to do it in many ways, but sometimes the nature of the bug or the standard needs to be implemented little by little, which is unfortunate, but kind of a reality that we had to deal with. So who decides on these standards? For us, we had a couple different ways that they were decided on. The first was a committee of interested individuals. That's what we did for our Angular. So we use Angular, like I said, and for Angular standards, conventions, there were a few of us that felt very strongly about the quality of our Angular code. And so we got together, came up with these standards, and were then able to enforce them. For JavaScript and TypeScript standards that affected everyone more broadly, we sent out a survey, got everybody's preferences back, and kind of took the majority vote on most of those. And then the other way is sometimes the person or team working on it just needs to make an executive decision. This is usually when there's less opinion and more hard reasons for this. For example, foo.bar versus foo.parens.bar. Sometimes with compiling and name mingling, you have to prefer one over the other. Similarly, Angular directory structure, there is a standard that's that Google recommends, and we decided to follow that standard, not really up for debate in the organization. So then the question becomes, who gets to, or has to, sometimes make this change, right? For us, again, multiple strategies based on the standard. For one, the first way is the person that's most interested in it. This is what we did for our injector. About a year ago, one of our engineers decided that managing dependencies was too much of a pain in the butt, and so he wrote an injector from scratch, and it is now used throughout our entire code base, and it has helped us a lot, and it's now pervasive. The other way is you make a dedicated team. This is what I experienced. We created a team with 4 engineers that would actually go through and make these changes that we decided on. So next step, how do you actually automate this work? Some of it has to be done manually, but as much as possible, it really helps to automate it. And so I'm going to go through a couple of tools here that we were able to automate this work and really save us a ton of time. And as I'll get to in a little bit, it also helps with the quality and quality assurance. So first one up there, using the Node.js file system API. This is what I was able to use this to change our file names. We decided that we would have a convention based on Angular's convention to have all of our .html files be .component.html. And so since this wasn't how we were doing it, I used the file system API to make this change and update all references to these files. We were also able to use abstract syntax tree tools, which this is Ryan Stringham. He was able to write a lot of tools for things like adding semicolons because it's optional in JavaScript, but we didn't want it to be optional. So we enforced adding semicolons. We were able to also enforce const over lets over vars. So now in our code base, those preferences are enforced as much as they can be. We also have then just the formatter in general for things like spacing and where did curly braces go, and we use the Clang formatter for that. We've also used parsing tools from the Angular compiler. This allows us to enforce formatting on our HTML templates, our Angular HTML templates. Again, things like spacing, where do we use new lines, stuff like that. To go on with that, a couple additional tools that we've used, we were able to write an extension for VS Code that helped us when we were moving files around and changing the file structure. Ryan Stringham wrote an extension that everybody can use if you want to, that allows you to move a file and then it'll find all references to that file and update that reference so that you are more consistent. In addition, we used a program or a tool called Gents that allowed us to convert all of our Closure.js into type-safe TypeScript. Something that I'll talk about a little bit more in the future, but Gents was a critical tool in that. So another question, something that we had to decide, is which standards should break the build if they're not followed? Again, this can't be all of them for various reasons. There's lots of standards, but we were able to make some of our standards actually break the build, which is wonderful. Again, this, as much as possible, this should be preferred, but it can only really be done when these standards are automated, unambiguous, and consistent. So you'll notice this is kind of a subset of some of these automatic changes that we made. But these are the ones that we could do consistently, and we were happy to enforce. And it makes it really nice to enforce that so that we don't have to trust the engineers and have them reintroduce issues back into the code. So another question, how do you mitigate the risk of so many changes? Because we were making a lot of changes. We touched, over the summer, we probably touched every single file, and I should have put this as another disclaimer. If you want to do this route, just be aware that your Git history will be completely botched. So one thing that really helps is mitigating the risk of these changes, right? So first step, compiler's your friend. So it is worth taking the time to find out what the compiler will find and what it won't find. For me, this is some Angular syntax where a Lucid button has a value input, and if you misspell it, but you don't use square bracket notation, then it won't complain at you. But if you do use square bracket notation, it will complain at you. Angular allows you to use either or, but it won't yell at you if you mess up if you're not using the Angular or the square brackets. So taking the time to understand what the compiler will and won't find is crucial, because if the compiler won't find something for you, it is up to code reviews, which can be very tedious, but we had to eat this cost as well. For code changes that weren't caught by the compiler, such as CSS changes or sometimes naming changes, depending on the naming, you actually have to walk through the code review very, very carefully. And this required walking through many thousand-line code reviews and being very thorough. But for us, it was worth the cost. The other step to remember is you have to be honest and upfront with your QA members. Even though sometimes it hurts to tell them, like, hey, the changes that we just made could affect anything in the product. We were able to have this honest communication with them, let them know so that they could be aware of it. And then when they came across issues, they could very easily come to us and say, hey, this thing broke. You said you made the changes. Does this look like what you were talking about? And having that communication was very important for us. So kind of one last caveat. When all else fails, put 6 engineers in a room for 3 days straight. So this is something that happened this summer. About a month ago, we had a company hackathon. And one of our more ambitious, probably most ambitious teams, decided that they were going to convert 600,000 lines of JavaScript to TypeScript. We all thought it was impossible. Those 6 did not. Actually, I'm pretty sure only one of them thought it was actually possible. But they all worked on it 3 days straight, no sleep, and were able to successfully convert, like I said, those 600,000 lines of JavaScript to TypeScript, maintaining type safety from the closure annotations through to the TypeScript. This was a massive feat that was only possible because we had the hackathon for those 3 days, and the code base was basically stagnant while everybody else worked on side projects. This, if not for this big bang change over those 3 days, this probably would have taken us roughly a year, maybe 2 years even, to slowly change JavaScript to TypeScript. And this was an amazing feat that this team did. Again, shout out to Gents, the tool that helped us with this process. So sometimes just pure manpower is what's necessary. So that was a lot of things that we've experienced ourselves, ways that we've handled them. Hopefully, we can help you avoid some of this. I think it's inevitable in all projects eventually, but hopefully we can mitigate that. So obviously, first one, think about the consequences of your decisions. A lot of the small decisions that we make, especially at the beginning of a project, end up proliferating and having a big impact and can then be hard to go back and change. Another one, decide on standards early, even if this is just one engineer and before you've grown to many engineers, decide on standards and hold to them. If you can, like the third point says, enforce them as strictly as possible. Again, this isn't always possible, but in as much as it is, they should be enforced so that you're not just relying on human remembering, which can get tough as your engineering department grows. And of course, this last one, once you notice that something should change, try to eat the cost as soon as you can. Because as more engineers come in, if they proliferate the bad practices, the cost to change is going to be worse and worse. If you're going to eventually have to make the change, it's probably better to eat the cost up front. Obviously, this isn't always possible because there's business concerns and features need to get out and the product needs to go forward. However, as much as possible, we should be pushing to improve the quality of the code base as soon as possible. So, how to do on time? Okay, well, that's kind of everything I had prepared. We have a couple minutes for questions if you have them. 5 minutes as needed.
How did you reduce or mitigate merge conflicts when you have one team that's changing the entire code base, but other teams still need to keep working?
Yeah, great question. So on that case, one part was just kind of open communication. That was kind of a theme throughout this entire process, was just kind of letting know. We have a dev channel in Slack just saying, hey guys, we just changed how we do all naming, so be aware of that, rebase quickly and take care of it. Some of the conflicts are unavoidable. Usually with enough warning, people were able to rebase and deal with it. The real issue came when we weren't communicating or when somebody didn't rebase right away, and then maybe it's a week later and they're coming across really odd changes, or even worse, right before we release, or maybe not right before we release, but right before we cut, as we're getting close to cutting our branch for release, if people are still trying to make changes and that's when they find your changes, that's a really big issue. So we would also we work on a 2-week release cycle, and so as much as possible, we would try to introduce the largest changes that were most potentially impactful at the beginning of a sprint so that people had 2 weeks to recognize those changes. Other questions?
Did you have those build checks run on the developer's machine as well as on the configuration server, or did they have to wait until they got the CI server to catch those issues?
Yeah, so it depended for some of them. The absolute final check, or if engineers wanted to run the commands on their local machine, we have just make commands. We use our make file extensively. So they can run the commands that are going to be run on the server. We use Jenkins for our build management. And so the soonest that it's forced upon them is once they push, even before it's like merge to master. Once they push, it'll start the builds, and that's when it'll fail. But if engineers are smart and want to save time, then most of us would run those commands locally first. But it wasn't forced on us. Other questions?
Did you guys use linting tool at all? And if so, how did that change, or how did that impact this?
I don't think so. I think we avoided linting tools because of the potential conflicts. So we use the formatter. That's all I'm aware of. If any of my coworkers here are here and can provide additional insight, then they can correct me. Let's go. Yeah, you right there. Unit tests. Not as many as we probably should have. Thinking right now off the top of my head, I can't think of any specifically. We were relying on a lot of our existing unit tests. Additionally, a lot of the changes that we made when we would consider unit tests kind of didn't make sense. For example, if you change the name of every file in the system, I'm not quite sure what unit test we could have written to find that. For that one, it was mostly compiler checks. And so unit tests, unfortunately for us, weren't as useful. There's probably ways that we could have used them more extensively, but we did not.
Yeah, you're talking about tools that are using to automate a lot of the changes, some of the changes. Did you just roll your own tools, or are there tools out there that you can use? Did you open source them? We're going through a similar.
Yeah. So we tried to use existing tools as much as possible. The ones that were most useful to us, so like you can see right here, Node.js was very helpful for me. That was really nice for reading contents of files and doing just straight string manipulation on them, or file name stuff. For stuff more sophisticated, I highly recommend looking up any kind of AST tools that you can find for whatever language you're using. We were able to find AST tools for TypeScript and JavaScript, which was fantastic. This allowed us to do some changes that I didn't even think were possible, such as adding semicolons consistently checking and making sure, like enforcing const let var, and then kind of the general formatting. I would highly recommend trying to find as many tools as possible. We didn't end up having to write too many homegrown tools. Most of our tools were kind of wrappers around these.
What did your test coverage look like before you made these big bang changes? And did you get a lot of errors that came out of them?
In terms of, when you say test coverage, do you mean like lines of code? Yeah.
Yeah, essentially lines of code.
I wish I had a percentage for you. It's lower than I would have wanted. Let's see. Thinking about tests that failed because of our changes. So really, yeah, the question, I guess, becomes, did our unit tests act as quality control for us? Off the top of my head, I can't think of any error that was found by unit tests that could have been, but I also can't think of any that got through to like the QA members that could have been caught by a unit test. Like I said, a lot of these ended up being kind of odd changes that were pretty hard to verify. I always believe in more unit tests, and I'm sure that if we had them, they probably would have been more useful, especially when it comes to things like modifying our HTML templates in Angular. Those are things that if we unit test our components very well, I'm sure that would help us to find a lot of those changes and the things that we did. Okay, so I think we're going to wrap it up. I'm going to be just outside these doors. If you have additional questions or want to talk about more things, I'll be out there, but thank you for coming to this presentation.